So at this point of the section, you know all about consuming promises, but we have never actually built our own promise. And so let's do that in this lecture. And let's go back to our lottery example from the slides and basically simulate a lottery using a promise here. And remember that in that example, a fulfilled promise means to win the lottery, while a rejected promise means to lose. So let's get to work, and we create a new promise using the promise constructor. So that's new promise like this. So just like many other built-in objects. And so what this means is that promises are essentially just a special kind of object in JavaScript. Now, the promise constructor takes exactly one argument, and that is the so-called executor function. So we need to pass in a function here. And so again, this one is called executor. Now, as soon as the promise constructor runs, it will automatically execute this executor function that we pass in. And as it executes this function here, it will do so by passing in two other arguments. And those arguments are the resolve and the reject functions. So reject like this. So we will use them here in a second, but for now, let's actually build this executor function. And also, we should probably store the result, so this new promise, in some variable. So lottery promise. Okay, so all of this here will create a new promise that we're going to store into this variable. So it's just like, for example, the fetch function, which also creates a new promise. Now, this executor function that we specified here is the function which will contain the asynchronous behavior that we're trying to handle with the promise. So this executor function should eventually produce a result value. So the value that's basically going to be the future value of the promise. And so let's do exactly that right here in the executor function, and starting with a simplified version. Now, in our lottery example, let's say that we actually win in 50% of the cases and lose in the other 50%. So a very simplified example, just to make this a bit more fun. And so what I'm going to do is to simply generate a random number, which remember is going to be between 0 and 1. And so I can simply say, if this number here is greater or equal than 0.5, then I want to call the resolve function. And so now this is where this resolve function that was passed into the executor function comes into play. All right. So in this situation here, we say that we win the lottery. And so therefore, that means a fulfilled promise. And in order to set the promise as fulfilled, we use the resolve function. So basically calling the resolve function like this will mark this promise as a fulfilled promise, which we can also say a resolved promise. And that's the reason why this method here is called resolve. Now into the resolved function here, we pass the fulfilled value of the promise so that it can later be consumed with the then method, right? So of course, we are going to handle the result of this promise just like we handled any other promise with the then method. So again, whatever value we pass into the resolve function here is going to be the result of the promise that will be available in the then handler. And so in this case, let's simply pass in a string here, and let's use some emoji again to make it a bit more fun. And so now let's handle the opposite case. So where we basically want to mark this promise as rejected. And so as you can imagine, for that, we can call the reject function. Then into the reject function, we pass in the error message that we later want to be able in the catch handler. So in the catch method, right? So here, let's just say you lost your money. and then just some poop emoji. All right, so give this a save here. So just to quickly recap before we consume this promise, here we created an executor function which is going to be called by this promise constructor as soon as it runs. So basically immediately, right? Then the promise calls this function and passes in the resolve and the reject functions so that we can then use them to mark the promise as either resolved, so as fulfilled, or as rejected. And so you see that this promise is eventually going to move to either the fulfilled state or the rejected state. So we always need to make sure that the promise ends up in one of these two states. All right, and so now it's time to actually try this out by consuming this promise that we just built. So lottery promise is going to be a promise object at this point, and so then, as always, we can call the then method. And then, just like before, the then method needs a callback function that is going to be called with the resolved value of the promise. So let's call this res here. And then let's simply log it to the console. Okay, and of course, once again, this could be any name here, right? And now let's also catch any errors. And so here also, as always, we will simply log it to the console as an error. Now, okay, and so that's actually it already. So what do you think this res value here is going to be, or this error is going to be? Well, as I just explained before, the resolved value of the promise is going to be this one that we pass in here. And so therefore, the value that we're going to log in the case that the promise is successful is going to be exactly this string that we passed into the resolve function. And the same is true with the error. So the error here is going to be simply this one, because that's the string that we passed into the reject function. Okay, so let's see. And indeed, we get or error. So you lost your money. And so as we keep reloading, we should then see these different states according to this random number that was generated here. Great. So now we won. And so as we keep doing this, we can see the different states that the promise will take. So that's amazing. But however, right now, this is not really asynchronous yet, right? So let's actually simulate this lottery draw by adding a simple timer. And so this timer will then simulate the time that is passed between buying the lottery ticket and actually getting the result. So let's add a set timeout here. So with a simple callback function, and let's run it for 2 seconds. And here we will simply take this code and put it here. And then we can also immediately log something to the console, like lottery draw is happening. And then let's add like a crystal ball here. So that's exactly also what we had in the slides. All right. And now another thing that we can do is to, instead of passing just a string here, we can also create a new error object. So basically creating a real error. And so that's a little bit better. So just like this. And so with this, we made this whole promise here make a little bit more sense, because now by using this timer, we did actually encapsulate some asynchronous behavior into this promise. And so that's the whole point of promises in the first place, right? So let's give it a save to see what happens. So immediately we get this here, and then after 2 seconds, the promise was resolved. And so then here we handled that result and logged it to the console. Let's try again. And of course, again, this one comes immediately. And we win again. Let's see if we can lose. Apparently, we can only ever win. But here you go. So now we get the error message just like before, but we also now see that it's an error, and it also tells us where this error is coming from. So right at line 292, so that's right here. And so indeed, actually creating a new error object is actually a bit better. Great. So this is how we encapsulate any asynchronous behavior into a promise. So how we abstract it away in a very nice way, just like we did here, right? And then all we have to do is to consume that promise like this. And so this is a really nice and helpful pattern. Now in practice, most of the time, all we actually do is to consume promises. And we usually only build promises to basically wrap old callback-based functions into promises. And this is a process that we call promisifying. So basically, promisifying means to convert callback-based asynchronous behavior to promise-based. All right. So let's see that in action a little bit. And so what we're going to do is to actually promisify the setTimeout function and create a wait function. Okay. So let's create a function called wait. And this function is going to take in a number of seconds. Okay. And so now inside of this function, we will actually create and return the promise. So usually that's always what we do. So creating a function and then from there returning a promise. And so this will then encapsulate the asynchronous operation even further. So essentially that's also what the fetch function does, right? So it's a function that returns a promise. And so that is exactly what we will do here with this wait function. So in a sense, this here is a more real world example. So promisifying setTimeout. So as I was saying, we are going to return a new promise. And then our executor function as always, and then resolve. And in this case, we actually don't even need the reject function. And that's because it's actually impossible for the timer to fail. And so therefore, we will never mark this promise as rejected. And so here we don't even need to specify that reject parameter. All right. So it's just like the array methods like map, which always receive 3 arguments, but most of the time we just use 1 or 2 of them, right? And so this is similar. But anyway, all we have to do now is to use setTimeout. And then here the callback function that we want to be called after a certain time is exactly the resolve function. So we can simply do this. And in this case, we're actually not even going to pass any resolved value into the resolve function because that's actually not mandatory. And so in the case of this timer, it's also not really necessary. And so in the case of a timer, it's also not really necessary to wait for some value, right? So in this case, all we want to do is to basically make our code wait. And so no resolved values are needed. Now here we want to run that timer for a certain amount of seconds. So we need to multiply that by 1,000. And so that's actually already it. Now we could improve this even further here, or just make it smaller by using arrow functions. And you can do that if you want to have some fun with that. But for now, I will simply now consume this promise. So let's call our wait function. All right. And so this will now create a promise that will wait for 2 seconds. And after these 2 seconds, it will resolve. And so we can then handle that. And then here in our callback function, remember, we are not going to receive any resolved value. So we just leave this empty. And then I will simply log, I waited for 2 seconds. And so here in this callback, we could now run any code that we wanted to be executed after 2 seconds, right? And then let's actually wait 1 more second. And so just like before, we now have to return a new promise here. So return, wait, and this time just 1 second. And so this is exactly what we did before when we wanted to chain 2 sequential AJAX calls using the fetch function, right? So in the result of the first fetch, we would create a new fetch and return it. And so that's what we're doing here. And so then therefore, all of this returns a new promise. And then we can 1 more time handle that. And let's just say again, I waited for 1 second. All right, so give it a save. So this one waited for 2 seconds and this one for 1 second. And of course, we also still get the result from the previous one. But for now, this is here what we are interested in. And so now with this, we have once again a nice chain of asynchronous behavior that happens nicely in a sequence, and all without the callback hell. So before, I actually showed you what happened when we had multiple timers. And so basically, we could do now this same thing like this. So let's just copy it here as a reference. And so this example here would be this. So 1 second passed. So let's just overwrite this one here. And then here we can simply duplicate this a couple of times. So 2 seconds passed, 3 seconds, and here 4 seconds passed. All right, and so that's going to be exactly the same result as we had here. Of course, here it's 4, but never mind, that doesn't really matter. What matters is that now we no longer have this ugly and difficult to understand callback hell, but instead we have this nice sequence of asynchronous behavior. Now finally, there is also actually a way to very easy create a fulfilled or a rejected promise immediately. And we had actually already done that in the previous lecture, but it's always good to know that we can do this. So let me show it to you again. So we can use promise.resolve. And so basically this is a static method on the promise constructor, right? And so here we can then pass in the resolved value. So just like we would pass the resolved value right here. Okay? So again, the difference is that this one here will resolve immediately. So here, it doesn't matter. So just ABC, and then we can handle that. And so again, the values here don't matter. And then we can also do the same with reject. Let's just duplicate this here actually. So reject, and here the then is not necessary because there will be no resolved value anyway. And so we can just catch it like this. And so these two here should now appear at the very beginning. Well, actually they don't. So let's see. Oh, actually here they are. So here is ABC and then ABC. Here let's just create a new error. All right. And so indeed, here we got a lot of redraws happening, which comes from the previous promise. So right from here. And so that's because this is basically the first microtask ever. And so therefore, this first microtask needs to be executed first. And then after these, we have ABC. and then the problem that we created here in the end. All right, so this is how we build our own promises and how we promisify a very simple callback-based asynchronous behavior function such as set timeout.